Hi viewers, welcome to LMS Solution. Today we are going to see about grid connected PV battery system with the PO MPPT. So here you will see that this is a simulating model for a grid connected PV battery system with the P and O MPPT. So this model consists of a PV array. So here you will open the PV array. So PV array consists of 8 panel. So they are connected in series. So each panel having maximum power around 250 watts, and then voltage at maximum power point will be 30.7 and current at maximum power point will be 8.15 amps. So 8 panel connected in series. So then we will have the voltage around 8 into 30 is around 245 volt, and then single panel having 250 watts, then the total power generation is around 250 into 8, so almost around 2000 watts. And here you will see that we can draw the IV and PV characteristics for a different irradiation condition. So here I am going to click this one. So when I am clicking that one, so you will see that the IV PV characteristics of the considered PV array. So for different irradiation level, here you will see that this is the peak point. Okay, so this peak point should be extracted from that means we have to operate that PV array in this point, so then only we can get the maximum power from the PV. If suppose we are going to operate the PV array in this point or in this point, so next you will see that, right? So you will get the minimum power only, so we are not getting a maximum power, okay, for the different irradiation conditions. So we must extract this point, or we need to make that operating of that PV in this point only. So for that purpose only we go for the maximum power point tracking algorithm. Okay, so here we are going to use P and O and MPPT, nothing but up and observe MPPT algorithm. So how it going to be work, I will explain you here. So here we have PV power and PV voltage. So for example, in P and MPPT, so you have to check 4 conditions. Okay, that means we have to check the 4 conditions for a change in voltage and a change in power. That means change in voltage going to be calculated between 2 instants. So for example, I am going to consider, so this is the first instant and this is the second instant. Okay, so just I am going to draw one line vertically towards that PV curve, and then I am going to draw another horizontal line here. Okay, for example, you consider this a current instant, so this is previous instant, and this is current instant, and this is previous instant. Okay, so you have to take the difference between the current instant value to previous instant value. So current instant here you will see that voltage, right? Voltage will be is less than previous instant. That means you have to take subtraction, right? If you take subtraction Ci minus Pi, then the voltage sign will be negative. Okay, and then here also you will see that, right, the current instant is very low than previous, you will take Ci minus Pi, that sign will be negative. So if both sign, right, that means so this is known as del P and this is known as del V. Okay, the sign of both del P and del V is negative. If sign of both del P and del V is positive, so here we need to move the voltage point. Okay, because the peak point is available here. Okay, so we need to make operating voltage of the PV is at this point. Now currently we have the voltage will be in this point. Okay, so we need to move the voltage from this point to this point, so then we have to move this point towards this direction. Okay, so when we have to move this direction, here we need to increase the voltage. Okay, concept is increase the voltage when del P and del V both are negative or positive, so we need to increment the voltage of the PV panel. So in here the PV going to be connected to the DC bus through that boost converter. Okay, so when we have to increment the voltage, we need to decrement the duty cycle. So condition for duty cycle will be we need to decrement the duty cycle when both sign having positive. Okay, if both having different sign, okay, both having different sign, So that means this operating region will be occur in the left side, okay, left side of the PV IV characteristics, okay. So del P del V will have different sign, okay. So that can be occur in the right side of the PV IV characteristics, okay. If both having different sign, del B is positive, so negative, and del V is positive. If del B is positive or del V is negative, then we need to decrease the voltage. For example, so this will be occur here, okay. So this point will be occur here. So I am going to consider, so this is CI and this is PI, okay, and this is EI and this is PI. So now here you will see that, right? So CI, right, CI of voltage will be higher voltage, PI having lower voltage, though then sign will be positive here. Here CI will be having lowest power, PI having highest power, then the sign will be negative, okay. So sign negative and the voltage change in del P is negative and del V is positive. Now system operate in this point, right, but the peak point will be occur here. So then we need to move this point towards to this point, okay. Then we need to decrement the voltage, okay. So when the system operate in the right side of the PV characteristics, so we need to move the voltage point, we need to decrease the voltage, okay. So if we want to decrement the voltage, then we need to increment the duty cycle. So this is a logic we need to apply in the PO MPPT in order to extract the maximum power from the PV array, okay. So how we apply that concept here? So here you will see that the PV array, right, so will be connected to the DC bus. So this is a DC bus and it will be connected via the boost converter, right. So this is a boost converter. So this boost converter will be controlled by means of this PO MPPT. So here we need to measure the, that means here we need to measure the PV parameter, and that PV parameter, that means we have to measure the PV voltage and current. The PV voltage and current will be processed via PO MPPT. So that PO MPPT will be generate the duty cycle. So that duty cycle going to be processed via PWM generator. So this PWM generator will be generate the PWM pulse, okay. So this pulse going to be used for control this IGBT of the boost converter to extract the maximum power from the PV array, as well as to boost the voltage from 245 volt to 400 volt for the DC bus, because so this DC bus going to be maintained at to 400 volt. So now I am going to click inside the PO MPPT. So here you will see that, so this is the logic of PO MPPT. So here we need to initialize this 4 parameter: initial duty cycle, maximum duty cycle, minimum duty cycle, small change in duty cycle, and then here we need to fix the 3 parameter, nothing but V volt, P volt, D volt, nothing but the previous instant voltage, power and duty cycle. So initially it does not have any values, so we have to fix V volt equal to 0, P volt equal to 0 at initial, and D volt we are going to keep which is equal, that means we have to maintain at the initial duty cycle, okay. And then here we have to calculate the PV power by using this formula V and I, and then here you have to calculate dV and dP. So next you have to check the condition, that means you have to check the sign whether both having same sign or different sign. So here you will see that the sign will be negative, sign will be negative. So then we need to decrement the duty cycle. If this condition is not true, okay, the sign will be positive, then we need to increment the duty cycle, okay. If suppose this condition is not true, okay, that means sign is positive, okay, then you have to check again this sign will be negative, means so we need to increment the duty cycle. If sign will be positive, means we need to decrement the duty cycle, okay. So after calculating the duty cycle value by using these conditions, so next process we need to check that the value of D value, right, that means it have maximum or minimum, right. So if it is within the limit, no problem, we have to use that duty cycle. If suppose the calculated duty cycle is more than D max or less than D minimum, then you have to keep that duty cycle, current duty cycle, which is equal to previous duty cycle. So after calculating this duty cycle, so next process you have to override the detail, right? That means the previous instant values, right? The previous instant value is overridden with the current instant values, and this program will keep on executing for every sample time, every 2 sample times for calculating the duty cycle. Okay, so finally you will get the duty cycle from this PO MPPT block. Okay, so then it going to be processed a Boolean generator, and it will be generated the pulse. So this pulse going to be control this IGBT to extract the maximum power. Okay, so this is a process of controlling the boost converter based upon PO MPPT in order to extract the maximum power from the PV panel. So next thing is, here we are going to connect that PV system to the DC bus, as well as we are going to use battery in the system. Why we are going to use battery here? During night time we don't have any solar irradiation, so we need to use some power to supply load during night time. So for the purpose, during daytime we are going to store the energy from the battery, and night time we can use that battery for supplying the load. Okay, for that purpose only here we are using battery. So here you can see that, so this sizing of battery is 240 volt, and the rated capacity we are taken is 48 Ah. Okay, initial state of charge will be 50%. So this is going to be connected to the bidirectional DC-DC converter. So this bidirectional DC-DC converter going to be control the current flow in the both direction. So it can operate in the both direction. That means it allow the current flow in the both direction. So because of this current in the both direction, so battery will be going for charging as well as discharging mode according with the power balance in the system. And also this bidirectional DC-DC converter going to be controlled by means of voltage control method. So why we are going to go for control the voltage? That means voltage control method. That means we need to maintain voltage of the DC bus around 400 volt. So in order to maintain that the DC bus volt is equal to 400 volt, so we need to control this bidirectional converter as a voltage control mode. That means we have to measure the voltage of the DC bus. So here we have to measure the voltage of the DC bus. So that going to be compared with the reference voltage 400, and it is going to be processed via PA controller. That means that error voltage going to be processed via PA controller. So it will be generated the duty cycle, and then it going to be processed via PWM generator. So it will be generate the pulse for that bidirectional converter. Okay, so this pulse will be used for control this 2 IGBT of this bidirectional converter in order to maintain that the DC bus voltage at 400 volt, as well as per the power balance in the system, the bidirectional converter will be operated in the both direction. Okay, next process we have grid inverter, and grid is connected by LCL filter, and then here we have the control logic. So this is a control logic. We have inverter control logic. Here we are going to use DQ control concept. Okay, so here we are going to control the inverter based upon the PV current and the SOC of the battery. So for that we have the control logic here, right? So we are checking the PV current and the SOC. If both PV current is less than 0.5, if SOC is less than 10%, so we are taking power from the grid, because there is no PV, there is no state of charge in the battery, then we must supply some power to the load. So that's why we are going to take the power from the grid. If the PV power is more than 0.5 and the SOC is more than 10%, we have excess power, right? That means we consider it have excess power, then we are going to send some power to the grid with the rating of 2 amps. So we are getting power from the grid at minus 10 amps. That means we are getting power around 10 amps current, and then we are sending power to the grid around 2 amps current. Okay, so here we will get the 2 amps current reference. So that need to be converted into sinusoidal form. So for that we are using PLL concept. So here we are going to measure the grid voltage, and then it going to be processed via PLL, and then it going to be PLL will be generated omega t. So omega t will be processed via sinusoidal block, and then you will get the sinusoidal reference. So that going to be multiplied with the reference current. So that will be a reference current for that inverter. Okay, so next it going to be converted in DP form. by using conversion transformation. So here we will get the D reference, Q reference. Okay, so this is a reference DQ value. Okay, so next you have to measure the IA. So the IA is going to be converted in a DQ form by using AB to DQ conversion. So after that you will get a DQ current value, actual value. So that going to be compared with the D and Q reference. So here you will see that inside we have a PA controller, right? So PA controller will be compare the actual Q and the actual Q reference. So Q reference, actual D value and the D reference, and then it going to be processed via PA controller, and it will be generate the duty cycle. Sorry, not duty cycle, control voltage in the form of D and Q. Then it going to be D and Q going to be converted into ABC form by using DQ to ABC conversion block. And finally we will take only the A quantity because we are using only single phase, and then it going to be processed via PWM generator. So this PWM generator will be generated the sinusoidal PWM for this inverter to control this current, okay, inverter current according with the reference current from this block. Okay, and here we have the load, right, DC load. Okay, so according with power generation, right, according with the that means PV current and associated battery, the total system will be going to be controlled in the system. And in between here you will see that here the measurement block. So here we have PV measurement, DC load measurement, battery measurement, and inverter grid measurement, and then we have that output of converter, all converter measurement, and power balance checking scope. Okay, so now and then here you will see that, right, here we are changing the radiation every 0.3 second from 1000 to 500, 500 to 10, and then again it changed to 500 and then change to 1 every 0.3 second. Okay, and then you have to check the results. Okay, so here I'm going to change the total time of simulation is 1.6%, and then I'm going to run this simulation results. So this is a voltage of the PV and current of the PV, power of the PV. So here you will see that, right, power generation of PV according with the radiation initially is around 1950 watts and then 1000 watts and then 0 watts, because radiation changed from 1000 to 500, 500 to 10 watts per meter square. So according with that change in irradiation, the PV power also changed, right? And then here change to 0 to 1000, 1000 to 2000. Okay, and here you will see that this is a battery voltage, so this is a battery current. So here you will see that, right, initially up to 0.3 second, right, there is excess power in the PV, so that's why a battery going for charging mode. After 0.3 second the power generation, that power from the PV is very less, so that's why battery going for discharging mode from 0.3 to 1.2 seconds battery in discharging mode, because the power generation is very less. So here you will see that the power generation is very less, is less than 1000 watts, because DC load we are consider only 1000. Okay, DC load is 1000. Okay, here you will see that. So this is a DC load, and then DC bus voltage maintained at 400 volt. So this is a DC load current. So DC load will be maintained around 1000 watts. And also as per this condition, because the associated battery is 50%, so we need to provide 2 amps current to the grid. Okay, 2 amps current in the sense it will be take around 300 watts. Okay, so totally 1000 plus 300, 1300 watts we need to take from the PV as well as battery. So that's why battery will be going for discharging mode from 0.3 to 1.2 seconds. Okay, because we need to manage that power of that 1300 watts. Okay, and here you will see that, so SOC of the battery is increasing because battery charging mode. So from 0.3 to 1.2 second SOC is decreasing, so because battery discharging mode, and again it going for charging mode. Okay, and here you will see that, so this is a inverter current and the grid current. So when I expand this one, you will see that we are sending 2 amps current, right, peak current, right, according with the generation. Okay, and also here you will see that, right, so this is a PV converter current. So here you will see that battery converter current and DC load current. So this is inverter current, and sum of all current which is equal to 0, right, that means system in balance condition, right. Summing of input and output current will be 0, system in balance condition. Okay, so next I am going to test the same model with when battery SOC is 9%. Okay, I am going to simulate this same model. Now battery SOC is 9% only, so you will check the detail. So up to 0.3 second, no problem, is it in same condition. 0.3, that means we will see that up to 0.6. After 0.6 the PV power goes to 0. So because of that, what happened, right, IPV is less than 0.5 and SOC already is less than 9%. So that's why what happened, right, we are getting power from the grid now. So here you will see that up to 0 to 0.6 we are sending power with a rating of 2 amps. After 0.6, right, we are getting power from the grid because the SOC of the battery is only 9%. So in order to charge the battery, we take some power from the grid. Okay, that means enough power from the grid to supply the load as well as charge the battery. Okay, so here also you will see that, right, the sum of current of a DC bus will maintain equal to 0. Okay, so now you can see that, right, after 0.6 seconds, right, the SOC of the batteries keep on increasing. That means it is in charging mode because the battery SOC only 9%. Okay, so in this mode we are getting power from the grid. Okay, so this is the working of the grid connected PV battery system with the PO MPPT. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.